Good morning. Okay. So we are on the other side of the midterm exam. The midterm, logistically, I don't want to spend a lot of time talking about it, but logistically, it kind of sucked. We lost a lot of time to slow down to the app. Uh, Overall, not a ton of time by my estimates. I think most of y'all lost like 10 to 20 minutes, which is a lot, but I think the concessions that I gave on the midterm more than made up for that. Uh, some of you reported higher numbers, but I still think the concessions made up for what we lost there. So we're on the other side of the midterm, and I'm basing that off of the results. The results for the midterm are higher. Y'all performed better in terms of final grades for the midterm than any other semester. So I think you might have also just performed better, but then also given the concessions, I think we're good on the midterm. Okay, so polymorphism coming up. Final deadlines. If you're watching final deadlines, task 4 just hit, of course, and task 5's coming up. It's probably a good time to give my opinion. Is once you make it through task 5, I think you're gonna make it through the whole course. It's very rare that somebody makes it through task 5 and can't finish 6, 7, and 8. And most of y'all who are still in it anyway have finished task 5 already as well. So that's really good to see. I'm getting pretty optimistic. I'll keep my expectations tempered, but I'm getting pretty optimistic at this point that you're all gonna perform pretty well this semester as a whole. So I'm excited about that. Hopefully we can keep that up. I don't want to get too ahead of myself on that one though. All right. Test 7. Let's do it. Test 7 in polymorphism. Who's ready to keep moving? And this is lecture 9 out of 10. After today, I am 90% done with material. Just Thursday's lecture on graphs to go, and that's it. Like that's the whole semester. Most of y'all don't have to take the final exam, so it's these 2 lectures, finishing up tests 7 and 8, and done with CSE116. It really does go fast. I've given warnings all semester, especially on day 1, about how fast this goes in the summer, and holy crap, it's almost over, just like that. It always, like, I know what to expect. I've been through this multiple times, and it still takes me off guard of how fast it goes. It's so fast. All right, so the media library class, this is what we want to build here. And this is going to use all 3 methods that you wrote for task 6, all 3 of the file reading methods. And we're going to add all of the content of all 3 files into this media library, which is going to mix songs and movies. And we're going to write all the code for the media library class in terms of ratables. So we're going to use the ratable class, that abstract class. Actually, I don't think I ever told you to make it abstract, but that ratable class, and code to the ratable class, and then the ratables themselves might be songs, they might be movies, and we don't care. We don't care what it actually is, we just care that it is a ratable. And that's going to show off the power of polymorphism, which is of course today's topic, and in my opinion the big payoff for setting up inheritance. Using inheritance is good for the reasons we talked about in the inheritance lecture. We can share code between classes and then update all of those classes by just updating the one class that they all extend, their one superclass. But the bigger payoff, in my opinion, is polymorphism. This idea that we can treat an object as though it were an object of the type of its superclass. And that's what we're going to see today. So for the media library method class, as a constructor that just doesn't do anything, it's just the default constructor. If you don't even write a constructor, you'll be right for this one, because it takes no parameters, it doesn't do anything. It's just the default constructor that you get if you don't even write a constructor. So effectively, it doesn't really have a constructor. Then it has a populate library method. So after you create a media library object, you'll call populate library, and this is going to take the 3 strings for the 3 files that you wrote for task 6, and then call all 3 of your task 6 methods. So you call your read songs method with the songs file name, you'll call the read movies with the movies file name, and then you'll call read movie ratings with the output of the read movies method and the movie ratings file name. And this is where it becomes important the way we set everything up with task 6. The output of those methods, they're never going to return an incomplete object. Specifically with movies. With songs, you just read the one file. It wasn't that big of a deal. But the way we set up the movie ratings method is we're never going to get a movie out of that method where we don't have all of the movie title, the movie cast, and at least 1 rating for the movie. So we're never going to have a movie or a song that doesn't have any ratings associated with it. So we're going to have complete data, nice sanitized, clean data. Everything in here has at least 1 rating. Then we don't have to worry about the edge case of, well, what about all these movies and songs with no ratings? We're not going to worry about it because everything has a rating because that's how we read the files. That's what we did in task 6, is a lot of setup for this objective here. And then the other method is top K ratables. So top K ratables is going to take an int, and you're going to return the top that many ratables, whatever that int is. So if you name that int K, that's where the name of the method comes from. The top K ratables, that takes an int, which is your value K. So for example, if you call top K ratables of 10, you're going to get a top 10 list. So it's the top 10 ratables, top K ratables, whatever one. If you would say K is 1, give me the top ratable, give me the best one. And this is going to be based on the Bayesian average with 2 extra ratings with value 3. So we're bringing Bayesian average into this. We're tying together, finally getting some payoff for a lot of these tasks that we did, tying together a lot of the tasks that we did earlier and seeing some of the payoff. This 7 and 8, tasks 7 and 8 really are the payoff tasks where we do a lot of setup earlier in the task. So we read all this data from all these files and show me the best ones on Bayesian average, and they can be songs or movies. And it's important for your testing to mix songs and movies together. And then making sure that top K ratables will give you the top K mix of songs and movies. So for example, if you put 100 songs and 100 movies into this media library and you ask for the top 5 ratables, you might get a mix of like 2 songs and 3 movies out of this thing. So we're going to mix the types in this and get each type returned. Since this is going to be coded to ratables, when you're testing, only check the titles. All my testing data, all the titles are going to be unique. So we're not going to have like a song that has the same title as a movie, for example, or 2 movies with the same title, which does happen in real life. For some reason, they make movies with the same titles as other movies. They do not have unique titles. But the data that I give you, the data that I gave you in task 6, does have unique titles. I sanitized the data, made sure I don't have any movies in there with duplicate titles. You don't have to worry about duplicate titles. And in your tests, don't use duplicate titles. So that way in your testing, you can check for uniqueness on titles. So top K ratables, and check if they give you the right titles in the right order. Which I should have, yeah. When testing top K ratables, check if they have the correct titles in the correct order, and that's it. So you don't have to go into the ratings like we've done all semester, where you go into the ratings, go into the cast, and check every value of these objects. Here, we're explicitly saying only check the titles. If it's the right titles, you can assume that the rest of the values are correct. Which we could do ratings too, but there's no reason to. And finally, the Bayesian average, like I've already put you through that all semester. And the way we're working with polymorphism through the ratable class, we do lose the ability to check the song artist, the song ID, and the movie cast. We kind of lose that ability. I guess we could do ratables. Maybe I'll change it next semester, but probably not. And then finally, don't write any tests where 2 songs or movies have the same Bayesian average rating. That gets tricky, so we're going to avoid that one. The reason this is so tricky is if 2 songs or movies have the same Bayesian average, then their relative order doesn't matter. So now you have to check for any ordering of that song or movie. And the issue with this is we could have truncation errors that change that ordering. Even if you have 2 Bayesian averages that are supposed to be different, but they're only different within a truncation error. Actually, that'd be really hard to set up. But any 2 movies with the same Bayesian average rating, their order might depend on like how we set up our Bayesian average methods. One might expose a truncation error and give them one order, and one might expose the truncation error to give them a different order. So your tests have to accept both orders. I guess you'd have to accept both orders anyway, but I'm not going to test it. You don't have to test it. Let's just avoid it. Keep things a little simpler. And to that extent, the testing utility method is much, much simpler than the previous task. The testing utility method of task 6, if you got that one, which if you're doing task 7, you got task 6 done. This one is way easier. Don't overthink this one. It's a lot more straightforward. I think my neighbor's playing music. I don't think it's loud enough to show up on stream, but I can hear it. To confirm, we can assume they will all have unique Bayesian average ratings. Yes. Yeah, and you obviously typed that before I just said, just went through that. I don't think I have anything else to point out with this. Don't have spaces in your file names. I had to add this note last semester because somebody had, out of hundreds of students who've done these assignments before, one of them last semester had spaces in their file names. That breaks everything. Don't put spaces in your file names. Like every file that I give you has underscores and no spaces. So if you follow my naming convention, you'll never have that issue. I never even thought that somebody would put a space in their file name. But I talked about that last lecture. Let's get on to some slides. And today we do have a little wiggle room in today's lecture. So today's lecture can be a little more chill than a lot of the other lectures. So if there's something that maybe I didn't cover very well, maybe I had to rush due to time constraints, especially last lecture was very rushed, very crunched. If there's something you want me to go back to, today would be a pretty good lecture to go back to those things. We have polymorphism examples. I'm just going to go through examples of whatever you want to see. There is a polymorphism memory diagram, which, by default I'll go through, but, most of y'all are done with memory diagrams. And I'm never going to make it, like on the final, I'm not going to throw polymorphism on that memory diagram just out of nowhere. I have already decided I'm not going to assess polymorphism on a memory diagram. So really it's these 24 slides of going through polymorphism. And then the examples, this is where I go to IntelliJ and do some live coding. So we got some good wiggle room. Today. Should be a nice chill lecture. So with that, so I'll be watching for questions. If you have questions on other tasks, and anything about the course, there's time today. Polymorphism. Let's talk about it. So let's talk about inheritance. So you can't do anything with polymorphism. Polymorphism does not exist if you don't have inheritance, which is always during the regular semesters. It's a good interview question. Explain the relationship between inheritance and polymorphism. Y'all got away with no interviews because there's just no time in the summer to interview you multiple times for all the extra chances and everything. It'd be a lot. but that's one of the best interview questions on this topic. What's the relationship between inheritance and polymorphism? The relationship is you don't have polymorphism without inheritance. So let's make sure we all know what inheritance is. Let's just remind ourselves what this is. So we had a game item class. This was our super class in inheritance. And then we had multiple classes that extend or inherit from that super class. So weapon and health potion here both get all of the state and behavior of the game item class. So weapon has X location, Y location, as well as damage. And health potion has X location, Y location, as well as increase. And they both get this use method from the game item class and the game item constructor. And the super class constructor must be called. I was very happy to see that very, very rarely on the midterm did anyone forget their super class constructor calls. I think that's what I have to do. I just have to say it like 100 times every lecture and make sure nobody forgets their super class constructor calls. There were a few students who still missed them, so I assume they don't watch lecture, but or it's possible they just forgot, of course. But we got them super class constructor calls, so I don't have to harp on it here. The super class constructor is always called, and we say weapon extends game item. And game item doesn't explicitly extend anything, so it implicitly extends the object class. So now the weapon class has the state and behavior of the weapon class, of course. That's just regular classes. It inherits all of the state and behavior of the game item class directly, so it has the state and behavior of the game item class. And since game item extends object, weapon indirectly extends game object and inherits all the state and behavior of, or object, so inherits all the state and behavior of the object class. So weapon has all of the state and behavior of all three of these classes, all within its definition. And these inheritance chains can get pretty long. You can have classes that have state and behavior of like 5 or 6 other classes in your programs by having these nice long inheritance chains and taking advantage of lots of inheritance, and then as we're headed, taking advantage of lots of polymorphism. And we call this an is-a relationship. I'm not big on all the vocab, but this one I think does help to explain what the relationship is. This is an is-a relationship where a weapon is a weapon, of course. A weapon is, in a very real sense, a weapon is a game item. And this is where it gets more interesting, more explanatory. A weapon doesn't just inherit the state and behavior of a game item. A weapon, in a very real sense, is a game item, and a weapon is an object. It really is all three of these types. It doesn't just inherit the state and behavior and like borrow from another class. It's extending the functionality of that class. So the weapon class, when we write this, we're saying you are a game item. We're going to start with the game item class and then add more functionality that's weapon specific to the game item class. But we have all of the state and behavior of the game item. We are a game item. So every weapon is a game item. Every weapon is an object. Anything you inherit either directly or indirectly, that object, an object of that type, is an object of all of its super types. And this is the same relationship of, from geometry, you've heard this forever. A square is a rectangle, but a rectangle is not a square. So it's not the other way around. Game item is not a weapon. Game item, the class, doesn't even know that the weapon class exists. The relationship is one way. So weapon definitely knows that game item exists, but in the game item code, you don't see the weapon class anywhere. Game item has no idea the weapon class exists, has no idea the health potion class exists, much less that they extend this class. But a weapon is a game item. Which finally brings us to polymorphism. If an object is a type with that is a relationship, so if it's one of its super types, if an object is a type, it can be stored in variables of that type. And that's it. You now know polymorphism. That is polymorphism right there. Now it's the implications of this fact that we have to talk about. So why would we ever want to do this, first of all? And what exactly do we mean by this? But if an object is a type, it can be stored in variables of that type. And this is where the name comes from. I'd be remiss if I didn't have a slide where I say what polymorphism is, because every polymorphism lecture, like, always has to break this down. So I'm gonna to polymorphism. Poly means many, morph means forms. Polymorphism, many forms. That's what polymorphism is. It just means many forms. So we're saying weapon has 3 separate forms here. Weapon can take the form of a weapon, can take the form of a game item, can take the form of an object, and by take the form of, I mean it can be stored in variables of those types. So all 3 of these assignments, this is what we mean by that. All 3 of these assignments are allowed. This is valid code. This code compiles, it executes, it runs, everything's perfectly fine with this code. This is valid code. We're going to create a new weapon object and store it in a variable of type weapon. That we've seen forever. Of course that's allowed. That better be allowed, or else we don't understand types at all. And they rewrote the Java compiler or something. Something really bad went wrong if that one doesn't work. The next one gets more interesting. This is polymorphism here. We're going to create a weapon object again, but now store it in a variable of type game item. So this is where we start breaking down that feature I showed in lecture 2 when I first said Java is strongly typed. The value type must match the variable type. Always, always, always. I said if you create a variable of type double, it can only ever store a double, ever, 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 ever. Which is still true. We're going to bend that a little bit, but it is still true because a weapon is a game item. We have a variable of type game item, but a weapon's a game item. So why can't I store a weapon in this variable? It is a game item. So I'm not breaking the rule. I'm storing an object of that type in a variable of that type, but the object happens to be one of the subtypes of this class. But that's still allowed because of the is-a relationship. A weapon is a game item. Same with object. I have a variable of type object, which you should almost never have. Only in pretty rare situations should you work with the object class directly. But any object ever, you can store in a variable of type object. Since everything extends object, you can store any object in a variable of type object. So this is also a valid assignment. You can even store a type parameter in a variable of type object, because everything has to extend object. So all 3 of those assignments are allowed. But why would we ever want to do that? Is a big question. Why would we ever want to store an object in a type that doesn't match its type, in a variable that doesn't match its type? Because that's what polymorphism really is. If you're just storing an object in a variable that matches its type, that's just regular variables. But once we store an object in a variable of one of its supertypes, that's when we're leveraging polymorphism. But why the hell would we ever do that? Seems like a silly thing to do at first. And the way I presented it in the previous slide, it absolutely is. This is a dumb thing to do. Don't ever do this. You would never do this. I'm just doing this for a lecture example. But there's no reason to ever do this. Just create an object and store it in a variable of one of its supertypes. It's kind of silly to do this. Actually, I'm not going to explain the why. I'm going to start with a downside. Before we even talk about why we would ever do this and why it's so powerful and why I'm so excited about polymorphism and it's the best thing ever and it's the big payoff of inheritance, I'm going to start off with the downside. I'm going to say, you know what? This is kind of, first of all, this is dumb to do, and this is why. We're about to explain why it's dumb to do, why you wouldn't want to do this, and then we'll start showing the payoffs of why this gets really, really powerful. Okay. You can only access the state and behavior of an object from a variable if that state and behavior is known to the variable type. So even though Weapon 2 and Weapon 3 store weapon objects, from these variables' perspective, they store a game item and an object. So from Weapon 2, I can only access the state and behavior that's known to the game item class. From weapon 3, I can do almost nothing with this weapon. I can only do the things that are known to the object class, which isn't much. So from weapon 3, I can convert it to a string with toString. I can call .equals on it and get its hash code. Like, I can't do much with weapon 3. I can only do the object stuff. With weapon 2, I can do a little bit more. Game item has a use method, so I can call .use on this thing, but I can't call get damage. Get damage is something that we wrote in the weapon class itself. It's only known to the weapon class, so I can only access that method through weapon 1 of type weapon because the game item class doesn't know that the get damage method exists. So I just can't call it. This doesn't compile. If I comment in either of these lines, this code no longer compiles, doesn't work anymore. So I can only access the state and behavior known to the variable type, but the method that's actually called will actually still be the method known to the subtype. So that part gets a little tricky. I think I will still do the memory diagram just to emphasize that point of how polymorphism works. Even though you don't have to do the memory diagram specifically, I think it's still a good way to show that off of what exactly I mean by that. And I'll say that multiple times, including in this slide. There's a lot of nuance to that. So the use method is written in the game item class. So the variable of type weapon, weapon 1, knows about the use method because what the weapon class inherits the use method from game item, so it knows about the use method, and we can call this is just fine. Weapon 2 of type game item, weapon 2.use, that's perfectly fine. We can call the use method from weapon 2 because game item knows about the use method. It's the class that defined the use method, so it knows about the use method. But from the object class, the object class does not know about the use method. That's specific to our code, not built into Java itself. So weapon 3 still can't call the use method. That call would not be allowed because the object class does not know about the use method. Now the variable is only deciding if the method can be called. This is a compiler check. It's just saying, it's looking through your code and saying, okay, I have a variable type game item and I'm calling the use method that takes a reference to a player object. Does the game item class know about such a method, a use method that takes a reference to a player object? It does, so the compiler passes, going down its checklist, it passes that check, and it allows your code to still compile with that call. So it's just checking if the code will compile. Is this a valid method call? And that's it. When the method is actually called, it's still called the same exact way we've been calling methods all semester, which is why I think polymorphism isn't really interesting on a memory diagram. You call the method the same exact way as we always have been. You go to the type of the object, not the type of the variable. You go to the type of the object to see which version of that method is called. So we would still get, even though weapon 2 is of type game item, when we call use, we do still get the weapon version of the method. So if the weapon class overrode the use method that it got from game item, we still get weapon specific behavior, but we need the game item class to know that this method exists for us to be able to access that behavior. So the variable type determines which methods can be called. The object type determines which method is called. So the variable type is just a compiler check to make sure that everything is, checks out, which is why this doesn't make good quiz content, because I'm not going to give you code that doesn't compile on a quiz. It's going to compile, so you just kind of ignore the advice I give in spring and fall semesters for the polymorphism quiz is just ignore that polymorphism even exists. Just ignore all of the variable types completely and just look at your object types, because the variable type just determines if the code will compile, and I'm not going to give you code like the answer on a memory diagram is never going to be this code doesn't compile, QED, and hand it in. Like that's never going to be your memory diagram. So it's just not super interesting in a memory diagram. But when you're coding, very powerful, very important to understand how all this works. Which is why I wasn't sad cutting it in the summer, cutting the polymorphism memory diagram. The object class doesn't have much power, but we can call, say, toString from all of these variables. And no matter what happens with overrides or whatever in all of these classes, these game item and weapon classes, all three of these toString method calls will return the same string. I guess there's a small asterisk on that one, unless I do something really silly in the toString method. But if it's a basic toString method that doesn't modify any instance variables, all three of those method calls are going to return the same string. The same version of the toString method will be called. I can say that 100%. The same version of the toString method is called with all three of these calls. The variable type only determines if this is a valid method call. It does not have any effect on what actually happens when the method is called. So if game item overrides toString and then weapon overrides that game item's toString, it's going to be the weapon's toString method that's called in all three instances. The variable type does not affect the method that's actually called, just determines if the method can be called. Okay. So why would we ever use this? So I say polymorphism's great, and then I lead out with a big downside, a huge limiting factor with polymorphism, where I say, well, you can store it in other variables, but all you do is lose functionality. Like, you can just do less with it. And I lead with that downside because I think the upside of polymorphism is so strong, so powerful, that I can start my sales pitch with, here's why polymorphism sucks. And it's still going to be amazing. It's going to blow your mind. You're going to be like, oh my God, polymorphism. Maybe not, but it is powerful. You might have to just believe me for a while. At some point in your career, you're going to be like, oh yeah, polymorphism. Yeah, this is pretty good. Once you really start coding with it and seeing the types of problems it solves. So let's get on with it. What's the good side of polymorphism? If it only restricts our functionality, and you should never do this, like you would never create an object and store it directly into a variable of one of its supertypes. There are some exceptions to that. There are times where I will do this, so I shouldn't say it so strongly. But for very specific reasons, I don't know. I can't really get into that now. By the end of lecture, I'll explain that if I remember. Okay. The advantage is to simplify other classes. So in the player class, we would have to have a use method for each type of game item. If we didn't use polymorphism, if we're only storing objects in variables that match their type, then when a player wants to use an item, we're going to have a use weapon method and a use health potion method. And in this case, all I want to do is call the item's use method. It's the item that decides what happens when the use method is called. So the player wants to use an item. They're just going to call the item's use method, which takes a reference to a player. We have a reference to the player that's using the item in this. So we're going to pass a reference to the player using the item to the use method and let the item decide what's going to happen. If it's a health potion, it's going to increase my health. If it's a weapon, it's going to increase my damage dealt, my damage output. But I'm going to let the item decide that. But now I have to have use weapon that takes a weapon, use health potion that takes a health potion, and then when I add 98 other item types to my game, I need 98 more methods in my player class. I need one for each item type, which is going to be a huge, huge pain in the ass to have all those methods. Every time I want to add, I want to add landmines to my game that I can place and then walk away and hopefully sabotage monsters or something, ambush them or whatever. I got to go to my player class again and add public void use landmine of landmine landmine.use of this. I got to add that every single time I add a new item to my game. And you might argue, like, that's not super bad. It's I'm going to cut and paste this and make some changes. You're going to have some risk of cut and paste errors, which are always a risk whenever you're cut and pasting code. You're going to forget to change the type or, something, the name, I don't know. You'll forget something at some point. I have a copy paste error. Still not the worst thing. But this is like the simplest version of the code. This is like the simplest possible thing you would have is a one-line method that just calls another method. The simplest version of this instance that you would have. What happens when you have your entire game engine that works with every different type that has methods for weapons, health potions, players, weapons? When you build an entire physics engine that you have to go back to your physics engine and say, oh, okay, we added bow and arrows to our game. We have to copy the entire physics engine again to be able to handle arrows traveling with a parabola through the air and being affected by gravity. You got to cut and paste all of that code that you wrote for the other objects in our game and rewrite it, copy and paste it for arrows, and now have that code, which also has to be maintained. If you find a bug anywhere in your physics engine, and now you have 100 different game item types, you have 100 different physics engines, and you have to update every single one of them, or you want to add a feature, maybe you want to go from 2D to 3D, was my example in the inheritance lecture. That's going to be a lot of work. You want to update the way objects collide with each other. You want to have more realistic physics there. You got to go update 100 different physics engines and 100 different game engines. Your entire game has to be duplicated. Nobody's going to do that. What's going to happen is you're going to quit programming because it's going to be so tedious and sucks so bad. You're not going to want to do it anymore. With polymorphism, we write our code for the super types. One use item method that takes a game item, and I don't care what item type this actually is, I'm going to call the use method. I know the use method that takes a player reference exists because it's known to the game item class. I don't know what it's going to do because I don't know what actual type item is. I just know that it is a game item. So I can call this. This is a valid call. And it's going to do the weapon-specific stuff, the health potion-specific stuff, the landmine-specific stuff, the bow and arrow-specific stuff. Whatever type it actually is, it's going to do that thing that it's supposed to do. And I don't know what that is. I mean, if you're playing the game, you should know what item you're using. But this code doesn't care that this use item method is called when you use an item. This method doesn't care what the actual type of item is. It just knows it is something that extends game item, which means that this code will compile because it has to have a use method. The game item guarantees that. The game item class guarantees it has to have a use item. Now your entire physics engine also works with game items. Game items has the location and move, and it would have all the, anything else that's related to the location of an object. We could also add hitboxes and things like that to the game item class. All of that information can be used by the physics engine, and then the physics engine can be coded to game item. One physics engine that works with game item. One game engine that works with game item. And you write all of your code generically to work with game items. And then you don't care what type of item it actually is. I might create new items and give them different hitboxes, different properties, different mass, and different physical characteristics. But the physics engine itself would just work with the game item class. And it would just care that it has all the functionality that a game item should have, which will be in the game item class. And then I write one physics engine. That's it. Without polymorphism, we really can't have different object types like this. We would have to have one game item class, and that game item class would have to be all-encompassing. We would say new game item and give it like a string for the type and all the properties we could ever possibly have for any game item would have to be in all game items, which could get a lot more tedious than and a lot harder to read the code than using polymorphism and inheritance. So this is why, I did get ahead of my slides. So this is why polymorphism. It's to make other code simpler. So we do lose a little functionality, and we would never just say game item equals new weapon. We wouldn't do that, like I said on the previous example. We wouldn't do that directly, just assign an object to a variable of one of its super types. But we do that assignment across method calls to make the method that we're calling simpler. So instead of having a whole bunch of different use item methods, a whole bunch of these, one for each type, we have one method that takes a game item, and now when we call this method, we do have game item equals some weapon, some health potion, whatever. But since the assignment is across a method call, that's where it gets powerful. Because now we have methods that are written to the super types, and they don't care which actual type you give them. This one method works for, if we have 100 different classes that extend game item, this one method works for 100 different types. That gets powerful. In a strongly typed language, it's something that we almost breathe a sigh of relief. Like that strong typing, we can relax that a little bit and write methods that work for lots of different types. This is nice. This is good. Otherwise, we'd be very hesitant to have different types if we had to write all of our code for each type. It'd get very, very tedious. So yeah, in this use item method, we can no longer access get damage from the weapon class. We can't get weapon specific stuff. We can't get health potion specific stuff. But we're willing to make that sacrifice here. This is where it gets worth it. If that's what I have to lose in order to not have 100 different methods here, I'm going to lose that. I'm fine with that. And then and usually in practice, if you're ever in a situation where you're like, man, I'd really like to be able to call get damage on this item because sometimes it's a weapon, and I want to call, I want to get its damage value or whatever. If you're ever in a situation where you really, really want that, in practice, what you usually do is take that get damage method and move it into the game item class. So if there's ever a case where you're too restricted due to polymorphism, you move that method up the inheritance chain, and then make every game item have a get damage method. Maybe you give it a default return 0, and then only actual weapons that it makes sense to have damage will return a non-zero value. They'll override the method and return whatever they want to return. And then like a health potion would return the default 0 and just not override it. That's typically what you would actually do. So you're not going to run into that restriction because you have access to all the code. Like you're writing the code. You can do whatever the hell you want. You're going to move that method up the inheritance chain so you can access that method. But wait, there's more. If we want to have, say, an inventory system, we have the same issue. I need an array list of weapons. I need an array list of health potions. I need an array list of arrows. I need an array list of bows. I need a lot of different data structures to store all of my items. And then picking up items, I'm going to need a method for each one of those items to add it to the correct array list. And using items from my inventory, even just computing, like, am I over encumbered? Is my inventory full? Can I add another item to my inventory? I got to loop through all of those separate data structures of all of those different item types. And that's going to be tedious. That code is going to look extremely gross, especially when I get up to 100 different item types. That's going to be absolutely horrible. And I don't want to write that code. I don't want to maintain that code. I don't want to have to add that 101st game item because I'm just going to absolutely dread editing that code ever. So I'm going to say, no, player, you don't get your feature requests. No, boss, we're not adding that to the game. We're not touching this because I'm sick of it. No, we're not going to do any of that, though. We're going to create an array list here in this case of the supertype. So not only can you store objects in variables of another type, you can also do this through type parameters. So if I have an array list of game item, this array list can store any game item. Any object that extends game item that is a game item can be stored in this array list. So our inventory is now an array list of game items, and it can be whatever game item we want to store in this. This one inventory variable is going to be able to store any game item. We don't care what it is. Any game item can go in there. And we can even loop over all the game items and call game item specific methods. If we want to use every item in our inventory, we can loop through all of them and call the use method because it exists in the game item class. And we know everything in our inventory has a use method because they all extend game item, and call that method while iterating over this data structure. So we don't have a whole bunch of array lists. We have one array list of game item that stores all them. This one, if the connection is not clear, let me make sure I spell it out. Your task 7, man, it really is task 7 already. Your task 7, you should have an array list of rateables. Somewhere in your code, you should have an array list of rateables. That array list of rateable can store songs and movies. Your writing methods that get top K rateables is going to return an array list of rateables. That array list can store songs and movies. You can mix them now in data structures of, I almost said game item, any data structure of type rateable can store both of those types. Any method that takes a rateable can take a movie or a song. Any method that returns a rateable can return a movie or a song. Any method that returns an array list of rateables can return an array list that contains a mix of movies and songs. So your top K rateables, I said it can return your top K lists, and that top K list of size 5 might have 2 songs and 3 movies. Yeah, because it's an array list of rateables, and that array list of rateable can mix any of the subtypes of the rateable class. Anything that extends rateable, anything that is a rateable can be returned in that array list. So song is a rateable, movie is a rateable. We can take advantage of polymorphism and return data structures that store songs and movies if the data structure is of type rateable. So that's the big power of polymorphism that you'll see in task 7, that we're mixing these two types. And of course it's just 2 types, but we can add other rateables. Maybe we want books and we have songs, we have movies, we have books, websites, journals, whatever we want to add to it. Hotels, whatever can be rated. Items for sale on Amazon, and then all the subtypes of items for an online retailer. Anything that can be rated, we extend rateable and use all our code and stuff it in our, I guess it's media library. If we're writing media library, it should be media. Live performance, that's not really. Speeches, I guess. Anything that can be rated and is media makes sense for task 7. We're just doing 2 for the homework. 2 is enough to make my point. And then I can say, in real life, this could be hundreds. But it could be hundreds. For the homework, I could add, books would be the next thing that would make the most sense to me. We could add books to our media library. But, I can make my point with 2. Why would I make you go through 3? But you should be able to see the point of, we can expand this. And that's where polymorphism really gets its power. Once it's lots and lots of classes. It's very powerful even with just 2. It's even more powerful if I have you go through the tedium of adding 10 different things that extend rateable. Top K rateables works for all of them. Mix them all up. Who cares? And somewhere in your media library class, I would expect you to have an array list of rateables. If I didn't make that completely clear. An array list of rateables. I'll give this away. This is the start of your homework. as an instance variable in array list of rateables. And your populate library method stuffs all of those songs and movies into that instance variable. And then when top k rateables is called, you go to that instance variable, sort by Bayesian average with whatever method you'd like. We've gone over multiple different ways of sorting. Choose your favorite one, or one that we didn't even cover in the course. You can use Java's built-in sorting method if you want, but you got to give it a Java comparator, the Java style comparator. However you want to sort, we have binary BSTs, binary search trees. We saw the insertion sort method. We've seen ways. Writing a comparator that is your Bayesian average comparator that you wrote for songs, writing another one of those for rateables, and sorting. Sort, and then grab the top K. It's really not that difficult of a homework compared to what you've gone through to get to this point. It's not as difficult as some of the homeworks you've done to get to this point, but it's meant to show off. It's not meant to just be tediously difficult. It's meant to show off the power of polymorphism, which I think it does. Okay, and that's really all I got on polymorphism. The next things I want to talk about are they're really inheritance topics. A few inheritance topics that the inheritance lecture just doesn't quite have room. Like all the content wouldn't have room to breathe if we stuffed this in the inheritance lecture. And if we didn't have them here, 852, like that would be all of polymorphism in 50 minutes, which would be one lecture out of the week during the other semesters, or 1/3 of a lecture in the summer. So there's just room here for these extra topics. So let's do them. Abstract. If you've done polymorphism in Java before, you're probably missing this and saying, when is he ever going to talk about this? Right now. Abstract, the keyword abstract and interfaces is what I want to talk about right now. So methods can be abstract, meaning they don't have a definition, which is crazy. What? We can have methods with no definition. All right, T down finally. We can have a method with no definition. So we're going to have an abstract method used that takes a player, the method that we've been calling throughout this lecture, and just cap it with a semicolon. Just don't give it a definition. This is allowed. This is legal. This is something we can do. Why would we do this? What does this do? Let's talk about it. So we can have an abstract method. It's a method with no definition, which, well, what should happen if this method's called? Like, methods exist to be called. So if we have an abstract method that has no definition, what happens when we call it? And with this one, it has return type void, so there's a valid argument to say, well, it should just do nothing, which is fine. But what happens if it has a return type? What if I have this return an int? What should be returned? Do you just have it return the default, like 0? Implicitly? Well, we don't have an answer to this. What should happen when an abstract method is called? I don't know. The Java compiler doesn't know either. The Java runtime doesn't know either. So it just can't be called. We're not allowed to call abstract methods. Can't be called. So we have methods that we created that we didn't give definitions to that can't be called. I promise you there's a reason to do this, but we got to get there. So we can't call this. And if a class has any abstract methods at all, the class itself must be abstract, and if a class is abstract, you can't instantiate that class. So once game item becomes abstract, I can no longer say new game item. I can't call its constructor and create an object of type game item because there's a chance if you create a new game item object that you might call the use method, which doesn't exist. It's abstract, it doesn't have a definition, and we don't know what an abstract method does, what it should do. So Java's protection against this is saying, well, if you have an abstract method, your class is abstract and you can't create objects of that type. So why would this ever exist? It exists only for inheritance in polymorphism. So the advantage of this, the reason for an abstract method is, let me see if I'm going to try to not get ahead of my slides. The reason for an abstract method is so that variables of type GameItem know that the use method exists. And it only exists to be overridden by subclasses, by child classes. So in the weapon class and in the GameItem class and in any other GameItem that we add to our game, if we extend GameItem, we have a responsibility to implement this method. We have to give this method a definition by overriding it, and then we can have that class be non-abstract. If we don't override this method, which we do have a little bit of a choice here, if we don't override the method, that is fine, but then that class also has to be abstract, which is something we might want to do. Like, weapon is very vague. Like, what the hell is a weapon? We might want the weapon class also to be abstract and then have sword, bow and arrow, hook shot, boomerang. We might want those classes all extending weapon and have one generic weapon class that's also abstract. We might want to do that. And then get damage can be abstract, and get damage can be overridden by each one of those subclasses to say how you exactly calculate the damage of each one of those specific weapon types. We might want to do that. But eventually, this method, if you want to be non-abstract and you want to be in this inheritance chain, you have to have a definition for the use method. It has to be somewhere in there. And the advantage that GameItem variables know that this method exists helps us with polymorphism. So if this method exists, then we can call it through GameItem objects. So we can do this to make sure that wherever we have a GameItem variable, that we can call this method because it's known to the GameItem class. So if we have a method that takes a GameItem, I know that it has a use method. I don't know what it's going to do, because what it's going to do is going to depend on the actual type of that object. But I know that it exists. It has to exist, or else Java wouldn't have let me get that object. The object wouldn't be able to be instantiated. Like, nothing could have worked to get to that point. So if I have a variable of type GameItem and it has a reference that's not null, it's a reference to an actual object on the heap, I know, I can guarantee that it has a use method that takes a player reference and returns void, and I can safely call that method. I don't know what it's going to do, but I can call it. What it's going to do depends on what actual type I have, if it's a weapon or a health potion or whatever else, but I know it will have this method. It has to, or else the code never would have compiled. So why abstract, though? Like, why not just give this, some definition and then override it in all the subclasses, which is what we've done all semester. Why not just have some default behavior here and make this non-abstract? We got away with that with everything so far, but it does get awkward at at certain points. The reason to not do that is sometimes there's no meaningful default behavior for the method. Sometimes we just want the method to exist in all subclasses. We're saying, hey, here's a contract. If you extend me, you have a contract that means you have to give this method a definition, because I want this method to exist, but I don't have any meaningful default behavior to give you. Like, we could say equal, or not equals, but we could say give this a body that does nothing, and for void that does kind of make sense still. But if this returns a value, it's not always clear what default value we want to return that makes sense for every single extending class. By saying that this is abstract, we're saying you must override this method. So each class that extends GameItem has to, forced to, make a decision. what do I want to do with the use method? What should this game item do? Because before, when we gave it default behavior, we printed to the screen item used. Like, that's not super interesting. And, for in the more practical sense, somebody extending game item might forget to override use, or they might override it and misspell use and not actually override it like we saw before, and they don't like their override annotations and they miss that. You don't have that issue with abstract methods because they have to override it now. Everybody who writes a class that extends game item has to make a decision of what the use method should do. They can't just say, forget that the use method has some default behavior that doesn't make sense. And they can't mistype use. Like, if this isn't overridden, they'll get a compiler error. So the compiler is going to help them out and say, even without the annotation, help them out and say, hey, you never overrode that abstract method. You must override that. And we saw this with our comparator. This is our best example of something that didn't make sense earlier in the class, is our comparator was a class, and the compare method had the default behavior of return false. Now that doesn't make sense, and we want to make sure nobody actually ever uses that default behavior. And we had examples where we had int instead of integer, and it sometimes overrode and sometimes didn't. We had to set it up in a specific way. I think that was in the other lecture. But we did set it up in a way where it looked like we're overriding, but we didn't if we didn't have our annotation anyway. And things got spotty, that we might get that return false behavior. Some of you might have, even while you're doing your task 5 and task 4, you might have accidentally gotten return false because you didn't override properly or extend properly. With abstract methods, that can't happen because you'll get a compiler error. The compiler will say, hey, you didn't override compare. So compare doesn't have a default behavior that makes sense. Return false is just what we gave it so our code would compile before we knew about abstract classes, abstract methods, and interfaces. We just did that so our code would compile. But now that we know about abstract methods, let's make compare abstract so we don't have any chance that you get the default behavior of return false. If a class has nothing but abstract methods, then we have the option to make it an interface. So comparator makes most sense to be an interface because it's one abstract method. That's the only thing this class has. We could make it an abstract class. We can make it a class like we did earlier in the semester. But it makes most sense for the comparator to be an interface, because it's one abstract method is the thing that makes the most sense. And if it's just one abstract method, make it an interface, which is like a class, but it only has abstract methods. Can't have anything else. Nothing else. No instance variables, no constructor, no methods with definitions, i.e. Non-abstract methods. Non-abstract methods are called concrete methods, and also non-abstract classes are called concrete classes. But I don't want to get too bogged down in the terminology. If you hear the word concrete, that means non-abstract. So we use the interface keyword. Now interfaces, just in case somebody wants to call me out on this, interfaces can have something other than abstract methods. They can have static methods and static variables. And there's also a new feature. I forgot to look into exactly how it works, but the default keyword, you can have methods with implementations that are non-static if you use the default keyword. I believe that means if nothing else implements that method, that is the default behavior. But if you have another method of that type, the defaults are all kicked out of there, which I can speculate as to what that does. I assume I know what that means, but I haven't looked up, so I don't know 100%. But there are a few other things you can have other than abstract methods, but abstract methods are really the reason you're using interfaces. And why would you ever use an interface? Why not just make these abstract classes? And the reason is you can only extend one class. Ever. You can only extend one class. If you have a class, it extends exactly one other class. Always. One single class. If you don't explicitly extend something, like int decreasing doesn't explicitly extend anything, so it implicitly extends object, and it still does even with the implementation here. Int decreasing extends object, implements comparative integer. So you can only extend one class. But you can implement as many interfaces as you want. You could implement 20 interfaces. No one's going to stop you. Java's not going to stop you for sure. Your colleagues might stop you because they might say, hey, you're going a little overboard with the interfaces. But Java's not going to stop you. The reason you can only extend one class is a problem called the diamond of death. If you extend two classes and both of those classes have a concrete method with the same signature, meaning same name, same parameter types, same parameter list, you're inheriting both of those methods, and then when you call that method, what definition should you get? If you inherited two different definitions for the same method from two different classes, and you call that method, which method should be called? I don't know. Java doesn't know. Java's going to say, well, just because that might happen, we're not going to let you extend multiple classes. So you just can't get two definitions for the same method. Problem solved. Bit overkill, maybe. But Java, that's the way Java rolls. If there's something that could possibly go wrong, they just don't let you do the thing that could possibly cause that. Other languages will let you get in trouble like that, by the way. C and C++ notoriously will let you do whatever you want. Well, within reason. But pretty much whatever you want. And it will let you do things like multiple inheritance like that. It's up to you to watch that and make sure that that doesn't happen. Because C++, if you have multiple inheritance, you inherit the same method twice. It's, you get one of those implementations. You're not going to know which one, but you'll get one of them. And your code's going to be very unpredictable. It'll be very unpredictable. And it will undoubtedly be buggy. But you just are careful enough to not let that happen. If you're extending multiple classes. Java just says, you can't extend multiple classes. But since interfaces have no concrete methods, there are no definitions to these methods, you can implement as many interfaces as you want. Because if I implement, say, two different interfaces, and it would be, I don't have an example of it, but it would be a comma-separated list, comparative integer, comma, whatever else, whatever other interfaces we want, we can implement multiple interfaces, as many as we want, because if we have two interfaces that we implement that both have the same method signature, well, that's no big deal. It's no conflict because neither of them have a definition. So if the comparator here says you have a contract, you must implement a method named compare that takes two parameters of type t and returns a Boolean, and then I implement another interface which says you need to implement a method named compare that takes two parameters of type t and returns a Boolean. Okay, I already had a contract. I already signed a contract that says I have to implement that method. So now I have to super implement it. I have to really implement that method now. Well, I was already going to implement it. I already had to implement it. I'm going to implement it. I'm going to give it a definition, and that's going to satisfy both of the interfaces. So you don't have the same issue with interfaces, which is why you can implement multiple interfaces. Last slide. And let's do this memory diagram. Oh man, what am I doing? There we go. Let's do this memory diagram. It's not a long one anyway, and then we'll do some live coding. I think this is a good opportunity to do some debugger stuff too. And again, if you have any questions, now is a good time to, whatever you're stuck with, to give some examples, hopefully things that pertain to many or most of you. If y'all have questions. If y'all don't have questions, I'm just left to my own devices. I'm going to show what I think would be interesting which might not necessarily be interesting or helpful, but hopefully is. I don't know. We'll have to see. All right, so here's some code that uses both extends and implements, just to show off that we can extend a class and also implement any number of interfaces, just one in this example. But I'm going to modify the weapon and potion. I'm going to shorten to potion instead of health potion just to fit better on the slide. Weapon and potion both extend game item like they always have in the past, but now they're also going to implement a usable interface, which is going to have that use method that we've been seeing all along. That use method is now going to be abstract, and the game item class is only going to have the location information, which I squashed down into one dimension, again, just to save space on the slide. And then each of these classes has to override the use method. They don't have a choice because this interface gives us an abstract method, has no definition, so it must be overridden in both classes. If it's not, which again is allowed, if it's not, then this class itself has to be abstract, which means we would not be able to instantiate it. You can't say new some abstract class type. Can't call the constructors. Can't do it. And then the player class is going to have their inventory and the use all items method. Those are the two things where we're going to take advantage of polymorphism. The inventory can take any usable, so we can use any type as our type parameters. That includes interfaces, which is really the reason why we would use interfaces, is so we can leverage polymorphism. Because an interface is just a list of methods that need to exist in anything that implements that interface. So we enable kind of multiple inheritance. It's not really, whether you want to say that's inheritance or not. If you're not inheriting anything, but you're inheriting the responsibility to implement some abstract methods. But the whole reason is so you can have multiple inheritance and leverage polymorphism. So I can have an array list of usable for anything that can be used in my game, used by a player in my game. But I also extend game item, so I can have my physics engine and my game engine that work with the game item class and do all of the game item stuff with that, which they don't care if those game items are usable or not, but my player cares that those game items are usable. And we could potentially have a class that is not a game item that is usable. That's something we can do. And no, we change this example to not. The player used to implement usable in this example. So that would be a case where it's not a game item, but it's usable, and a player can use another player, whatever that means. When we had the example set up in that way, a player using another player would attack that player. So it wouldn't make sense to have another player in your inventory. I think that's why we changed the example. But you can have something that's not a game item. As long as it implements the usable interface, it can be part of your inventory and it can be used by the player. This is the only time all of the code's going to be on screen all at once because I need room for the memory diagram itself. So this is the code that we're... so let's take a second to look at the whole program. We're going to create a player, a weapon, and a potion. Weapon's going to be stored in a variable type weapon, potion in a variable type usable. So in potion, we do lose some functionality. Again, we would never do this. We would just store it in a potion so we don't lose any functionality. But we do lose all of the potion specific stuff. And since it's stored in a variable of type usable, the only thing we can do is anything known to the usable class, which is just the use method. It's the only thing we can do with this potion anymore. It still is a potion. It still has all of this behavior. But we can't access any of it because we stored it in a variable of type usable. Now we do have to do that when we call the pickup method that takes a usable. All our game items or all of our weapons and potions have to be in a variable of type usable by the time it gets here. And now we're restricted to only calling the use method once we get into the player class. But we're accepting of that restriction in the player class because it lets us write one pickup method, one inventory array list, and one use all items method. which of course for an actual game you would like use an item by the index in your inventory. But just to show off a loop, I want to show off a loop that iterates over a data structure of an interface type and then call the use method on each of those, just so we can see that the use method is going to do something different based on the actual type of that inventory item. That's what we're getting towards. So call pickup on the weapon and potion, and then use all items to use the weapon and potion. So that's what our code is going to do. Let's see it in action with a memory diagram. Is it the last one of the semester? I do have slides for a memory diagram on graphs. I don't super want to go through it since I'm not assessing you on that at all. Maybe I will. I don't know. So this is possibly the last memory diagram. I wasn't even sure if I was going to do this one today. But I think it does emphasize the point. The graphs one really doesn't emphasize anything new. It's just there because when we have a quiz on graphs, then I feel obligated to cover it. But there's nothing new. Like you could do, if I gave you a quiz on graphs, code to trace that uses graphs, you would be able to trace it. If you can do the OOP and the DS on the midterm, you would be able to trace it. There's nothing new. It's array lists, it's hash maps, and that's it. I guess I didn't give you array lists or hash maps on the quiz, on the midterm, so, I mean, maybe not, but there's nothing new on it. All right, so new player constructor. We've seen that 100 times. Player does create a new array list. So inventory is a reference to an array list. Weapon and potion. Don't forget superclass constructor calls. Weapon gets damage and location. Gets instance variables from the class itself and any instance variables that it inherits from its superclass. I did see that mistake quite a bit on the midterm. Like not a lot, but a good handful of students missed the OOP quiz by not having the instance variables from the class itself and any superclass that it extended. So make sure you have that. But let's face it, those students don't watch lecture. Maybe they do. Maybe it was an innocent mistake and they just got caught up in the moment, especially with the chaos of the midterm. It's possible that one of you was here, but I think it's more likely that they don't watch lecture. It's just me. Given that, 12. I guess that ain't too bad. I mean, 12 out of 44, but it's still pretty low. But I think a lot of students do watch lecture after the fact, because when you're watching it live, you can only watch it at 1x speed. I think a lot of students like to watch it after it's recorded so they can watch it faster than that and skip around and stuff, which I don't recommend, but, you know, student's gonna student. I already said all that. Those slides were talking about the potion is restricted to just calling things from the usable interface, can't access potion-specific stuff, which there isn't really any potion-specific stuff in this example. Maybe I should add something to the potion class, but I had to fit everything on the screen, made it tough. So when I call pickup, this is where things start to get interesting, where we start to get to leverage polymorphism. Pickup weapon OX480 is of type weapon. So we're calling pickup of weapon of this object. So item is OX480. And here's where we have that hidden assignment line where we have usable item equals weapon. This is where we do have that assignment. Like I keep saying this one doesn't make sense when it's just all in one line. But when it's split between a method call, usable item equals weapon, usable item equals potion, that's where we have this assignment. That's where we do store variables of one type objects of one type in variables of one of its super types, is when it's across a method call. That's where this is really important. So usable item gets a reference to a weapon class. Item of type usable is storing a reference to a weapon object. And then in the next call, item of type usable stores a reference to a potion object. So I call this method twice with two different object types, and it worked both times because weapon and potion both implement the usable interface. And we'll call use all items. We're iterating over the usables in our inventory. So item is of type usable. I can only access the code in the usable class, anything known to the usable interface, which is only the use method, which happens to be the method I'm calling. So good thing there. Everything compiles, everything checks out. So we call the use method, and here's the other side of things where it gets more interesting. The type, method that's actually called depends on the type of the object. Now in this example, it's the variable type is an interface, so you really can't mess this one up. Even if it was a memory diagram, you would go to the interface and say, oh, that's abstract. There's no definition there. I must have to look somewhere else. So this wouldn't make a great quiz because it wouldn't test if you understand this concept. But for a lecture example, that's fine. But here's the thing. The use method, item.use of this. When we decide which method is called here, we don't look at the variable type at all. Like variable types don't even show up in our memory diagrams anywhere because they're not important during the execution of a program. They're important during compile time, during compilation, to decide if the code will compile. Is this valid code? But once you're getting to runtime, where you're executing the code and values are being stored in memory, you're long past compile time at that point. So the types of the variables don't matter anymore. We don't look at the type of the variable at all when we decide which method is being called. We do the same thing we've been doing all semester. Item.use of this. Item.use. So we're calling the use method from this object. We look at the type of the object. We go to that class, and we look for a use method that takes a player reference. And that's the method that's called. Same thing we've been doing all semester. We go to the heap, look at the type of the object that's calling the method, and that's what decides which method is called. Nowhere in that process do we ever say, well, what's the type of the item variable? We don't care. At runtime, we don't care. At compile time, we care a whole bunch. At runtime, we don't care. So when we call use, since OX480, this reference was to a weapon object, we still do get weapon-specific behavior because the object is of type weapon. So just because we stored that weapon in a variable of type usable doesn't mean we lost all of the characteristics of a weapon. It's still there, but we can only access it if it's known to the usable class, or the usable interface in this case. So the use method exists in the usable interface, which means that this is allowed. That this is allowed, and then the behavior we actually get depends on the object itself. So when we call use on the health potion, when we say item.use from this object, well, this object is of type potion. Same thing we've been doing all semester. Object type potion. Look in the potion class. Find a method named use. That's the method that's used. So it's the same procedure we've been doing all semester. Nothing changes just because the variable type doesn't match the object type anymore. That's fine. That's allowed through polymorphism. And then what actually happens, the behavior we actually get, is still the potion-specific behavior in this case. So the variable decides if the method call is allowed, but the object type still determines which method is actually called. Nothing changed there. Same thing that we've always been doing. Then we're at the end of our program. We used all our items. We picked up 2 items. We used them both. Memory diagram over. Okay, the rest of the lecture is live coding. Wait. I might just overwrite my starting point. I'm not gonna bother with that. So I have my aptly named starting point here. Wait, I gotta figure that out. Why didn't this? Can I just do summer? In decreasing. How did that happen? Let's just change that. Okay, so what we sorry about that. So what we want, let's make sure all my stuff compiles still. Can we ask task specific questions? Absolutely. Yeah, we got time here. We got pretty chill time. What I have here is the code where we left it at the end of the inheritance lecture, and I want to start throwing polymorphism at this and change it into code that leverages polymorphism. It's pretty open-ended. So it might look, by the time we're done, it might look like what we did in the slides. It might not. It probably won't. I don't really feel like doing the usable interface. I don't know if that really expands your understanding of polymorphism by doing it that way. But we'll make some changes. I think I'll start with sorting because this one's is much more straightforward. And I can show you an interface there. But if you have task-specific questions during this, I'm happy to go get sidetracked and go talk about something else within reason. If I think it's something that's too specific, I don't know. Let me just see what your question is. Intentionally vague. The Bayesian average is a double, and the rating parameter is an int. Would you recommend casting, or is there something obvious? I do not recommend casting. You should not cast ever all semester. I constantly see students casting. Don't cast anything. There's no reason. Everything's set up in a way in 116 where you should never have to cast ever, which is why I've never said that word in lecture until just now. Like, don't do cast. Okay, I think audio's back. I hit my mic and it knocked the cord out. Yeah, don't cast anything ever in this course. That's something that might be helpful in your careers at some point. Sometime you might want to cast. Not in 116. Okay, so Bayesian average is a double, but the parameters are ints. This is fine. So you can convert from int to double. Let me actually answer your question. You can convert from int to double without casting. So if I have int x equals 82, double y equals x, like I don't have to cast anything here. Going from int to double, you don't have to cast. It's when you're going from double to int that's where you get issues. So the way things are set up, you get ints, but you got to return a double. So there's no casting involved. Like I don't have to do this. It's unnecessary. Casting x to double is redundant. Because you have no precision loss. Every int can be represented as a double, but not vice versa. If I have a double that's like 2.3. I can't represent that as an int, but any integer value can be represented as a double. So we ain't got to worry about it. Now I have to make sure I'm right on that. Integer dot I don't know if we lose any precision here. I don't think we do, but well, maybe we do. Yeah, no, we didn't lose any precision. Yeah, you might have something up with your logic there. Also, isn't this a test 4 question? We're already past the final deadline of test 4. It has me a little concerned as well. All right. Yeah, you would compute the average, but pretending that those for test 7 you already wrote the Bayesian average method in test 4. You just call it the method that you already wrote. You shouldn't be re-implementing Bayesian in test 7. In test 7, the intent is you already have your Bayesian average comparator. I'm glad it's not a test 4 question, because that was getting awkward if that were the case. In test 7, you have your Bayesian average rating comparator that you wrote for songs. I would copy that class and change song to rateable and use that comparator with whatever sorting method you want to use. If you want to use the insertion sort that we're looking at right now, you can just grab this method. It's slow and inefficient, but whatever. It's not so slow that it's going to time out in Autolab. Or if you want to use that comparator for with a BST to get some more efficiency, as long as you're not inserting in sorted order, that'll be more efficient. But again, efficiency doesn't matter. Or if you want to sort some other way. But the intent, I leave it. I intentionally don't give you much detail on that one, because at this point you've seen lots of ways to sort. Task 7. You're at the point where I'm starting to say, okay, here's the task that you're given. You got to go into your toolbox and figure out how you want to accomplish this. So with sorting, my intent is that you would say, oh, we did sorting back in task 5 with BSTs and these comparators. Let me just create a comparator that does what I need it to do, that works with ratables instead of songs, and then throw it at my BST that I already have in this same project and call it a day. You do have to, that returns a linked list, so you do have to go through the linked list and convert that to an array list with k values. So there's a little bit of work if you want to use the BST, but if you use this insertion sort method, takes an array list, returns an array list, easy day. You just got to prepare the comparator. So you don't have to rewrite any of your Bayesian average code. You shouldn't be revisiting Bayesian average at all. It's already written. That's one of the key things that we want to do in programming, is once we write a method one time, we never want to think about it again. We write it, we test it, it works, just call that method. Okay, so you do insertion sort, rateable Bayesian average comparator, or whatever you end up calling it. And then your task is to write a comparator and reuse all of that code that's already there. Oh, I feel like I'm typing slow today. I need to get more rest. Oh. Okay. So what we want to do here, we have int increasing. We're actually not going to mess with the insertion sort code at all. But we will revisit that a little bit. But what we want to do is change this setup. So we had our comparator class. This is how we did it in task 4. We had our comparator class that returned false. We have this default behavior of compare, and then we would extend the comparator, give it its type parameter, and then implement the compare, override the compare method so it doesn't just return false, it does what we actually want it to do in our comparator concrete classes. That's what we did before, but we want to get rid of this because we don't want, some silly thing. We have like double, and we don't have our annotation. And now our comparator just returns false all the time. We don't want to do that. So let's get rid of this default behavior and make this an abstract method. And I'll show a few things here. I want to make this an abstract method, get rid of this default behavior, and if I have that as an abstract method, I have to make this an abstract class. But since this abstract class only has one abstract method, it has nothing but abstract methods, I'm going to go all the way, thinking ahead, all the way to interface. I'm going to make this an interface. And when I do, and you probably noticed this on the slides, I didn't say public or abstract in the slides. I just said Boolean compare TT is all I had. And that's because you don't have to specify these things. Modifier public is redundant for interface members. If it's an interface, it can only have abstract methods, and those methods also have to be public. It doesn't make sense to have an interface with non-public methods. So interfaces, they all have to be public abstract. Modifier abstract is redundant for interface methods. So this, gone. So I just do Boolean compare, and it's implied because it's an interface that this is a public abstract method. And I can do something like int x equals 9. I can do this. Now that looks like an instance variable. And you might say, oh, Jesse said this could never have instance variables because it's an interface, everything has to be abstract methods. This looks like an instance variable, but I can do the same thing. I can add the missing keywords because there's a lot of implications here. This is public, and it grays it out and says this is redundant. It's an interface, it has to be public. It also has to be static. I believe it has to be final. Yeah, it has to be final too. It has to be public, so that's redundant. It has to be static, so that's redundant. And it has to be final, so that's redundant. So my IDE is saying, yeah, I know it's a public static final variable because it's in an interface. It has to be public, static, and final. So you can have what looks like an instance variable, but it's actually a static constant. That's what this has to be, and realistically, I should name this with all capital letters because that's our naming convention for constants, for static constants. So this looks like an instance variable, but it's not. It has to be accessed through the comparator class. I can also have static methods. That's fine too, that are accessed through the comparator class. It doesn't always make sense. And comparator dot x, like I access x through the class because it's a static variable. I can't access it through objects that implement this interface. Can't do it. It's a static variable. It's accessed through the class itself. Static variables and static methods belong to the class. Non-static variables and methods belong to objects of that type. So just some kind of side content, but just to show that off. Interfaces, the interesting things are always the abstract methods. But it can have some static stuff. It cannot have instance variables. We can't do that. They will be static. So now I have errors over here because I can't extend an interface. I have to implement an interface. So I'm going to implement the comparator interface. And now everything's happy again. Everything works. I'm overriding that abstract method. If I don't override the method, I'm going to get an error here which says, hey, you implemented this interface, but you didn't implement all its abstract methods. That's fine if you yourself want to be abstract. If I can spell abstract. That's fine if you yourself want to be abstract. We'll allow that. And then you can extend int increasing and implement the method down the inheritance chain. But if you want to be a concrete class that can be instantiated, I'm saying you are allowed to say new int increasing here. If I want that, then I have to implement the method. I have to implement all the abstract methods that I inherited either through implementing interfaces or extending abstract classes. I have to override all of the abstract methods that I inherited. And then in insertion sort, this is one that kind of slipped by you and I said, don't worry about it. This is allowed. We'll talk about it later. Is comparator of t and then we said I'm going to give that a new int increasing. So we said comparator of t comparator equals new int increasing, and I said the types don't match, but that's actually okay because of polymorphism. Well, now we can finally understand what that means. Int increasing implements comparator of integer. So int increasing is a comparator of integers, and we're storing it in a variable of type comparator of t, and for this specific insertion sort instance, t is integer. So we need a comparator of integers, and we have int increasing, which implements the comparator of integer interface. So this is a valid assignment due to polymorphism because int increasing is a comparator of integer. So this assignment is allowed. We can call the constructor with an int increasing. We can store that int increasing in this instance variable of type comparator of t, which is integer for this instance. Everything's perfectly fine. If I change this to double, for example, now that's not okay. Int increasing is not a comparator of double, and all those assignments don't work anymore. But as long as the types are all matching, whether it's through inheritance or whatever, then all of these assignments are valid. And our sorting works fine still. Okay, now let's mangle up our game item code. So this is where we left it, and this has a bit of extra code that I don't like that IntelliJ constantly collapses my methods like that. So this is a little bit of extra code that we didn't see in the slides, but it's for the most part where we left the code when we ended inheritance. Except one thing which I actually want to undo. We have player extending game item. Oh, how bad is it going to be to undo that? I just think it's unnatural to have... Okay, we're good. I just think it's unnatural to have player extend game item. We had it for an example before, I don't know, and then a player using another player. I guess we didn't even, we just took the default item used method. Was a little, it was a little weird having players use other players. I don't know. I didn't like it. So I'm getting rid of that. And I didn't show it in the slides anyway. And the way the code is set up, the way we did this at the end of inheritance lecture is in a way that we could do this. Variable of type game item equals new game item, which took location. Like, this is allowed. We're allowed to do this the way the code was set up. Because game item, it's a concrete class. That's the way we set it up for inheritance. And every method that would be abstract has a default behavior associated with it. So creating a new game item of type game item is allowed, but this is something we usually don't want anyone doing. What does it mean to create a game item object? What does it mean as a player? You're playing this game and you have a game item object in your inventory, and then you try to use it. Like, what should that do? Like, what is that? It's nothing. It should be an abstract class because it's an abstract concept of a game item. I don't want a game item in my inventory. I want weapons. I want health potions. I want grenades. I want a the backpack, I guess, would be my inventory. I want rocks. Maybe I don't want rocks, but maybe I want gemstones in my inventory. I want actual things. I don't want abstract concepts in my inventory. So even if game item doesn't have any abstract methods, maybe you want a default behavior in every single for every single method. Even if that's the case, sometimes you still want to make the class abstract just to prevent people from doing this. Just to avoid this in your code. Because once you have an object of type game item out there, things can get strange. So if you don't want people doing that, even if there's no abstract methods, you can still make a class abstract. There's nothing stopping you from doing that. It's sometimes a good idea to do that. Now this doesn't compile. You can't create an instance of an abstract class, even if there's no abstract methods. So it's another tool that we can use to make our code a little more robust, to avoid those bugs. Because if somebody has a game item in their inventory, you're going to get some bugs. I want rocks. Yeah, we can have rocks. Let's extends game item. And now rock has everything that a game item should have. There's, oh yeah, the constructor. Public rock. Let's do weight. Is a double. What other property should a rock have? I think my locations are ints, if I'm not mistaken, and then super XY. Whoa, 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 whoa. Not like that. And then this dot weight equals weight private weight public. Oh, actually, I'll show this off a different way. We'll come back to the rock class. But when this is abstract, there are some methods that we will want abstract. This one is the big one in my sights. The use method, just printing item used, doesn't make a ton of sense. This is where last time I said, well, we could update inventory and do whatever else we need to do when an item's used. But the way we have things set up now, that would happen in the player class when the player, which doesn't have a use item method. Why don't we have use item in here? Oh, because I'm supposed to write it. That's what we do in this live example, is add the inventory. So I'll add it there. But the use method, this should be abstract. And this other use method, this should be abstract too. Actually, I'd be fine if this method doesn't exist. We don't need two use methods. This use method, was the one I used in lecture just to print things to the screen to simulate items being used. But really, when an item's used, it's used by a player. So we're going to just have the use method that takes a player reference, which is the player that is using that object. And now we're going to should have errors somewhere. I didn't have my annotation here, and I used the default here, so weapon should have some errors. Oh! It's always the most embarrassing when I'm trying to write errors and I don't get errors. Rock will, for sure. I didn't have my annotation here, so if I have my annotation, but this is one of the examples where I'm like, here, I'll use the annotation here, but not here to show you the difference. That's my example for that. But if I have the annotation, the override annotation for a method that no longer exists in the superclass, I should get an error here that says, hey, just to let you know, you're not overriding anything anymore. And in fact, I just want to get rid of this method entirely. We're just never gonna call that method. The health potion class never overrode that method. It just took the default behavior. This, I want my annotation. And now player, I don't have extending anymore, but I do want to add, just to get this in sync of what we saw in the slides, public void use item, which takes a game item and item dot use this, because we already saw this one in the slides. So one method, instead of public void use potion, health potion dot use this, public void use weapon dot use this, public void use rock dot use this. And then for every other item we want to adding another method. We don't want to do this. That was tedious to type. I didn't even like typing it just now for the example. We have one method that just takes any game item and calls its use method. Easy day. If we don't have this one, if we don't have this one, we can actually call this use item. We can get a little fancy with this and call these all use items. So you just call the use item method, and it's overloaded to take all the different parameters and then do the same thing for each of them. We can actually do this. So then at least they're all the same method name, and we just change the types all the time. But it's much easier to just have one method. Oh, that didn't even yell at me. I thought that was going to yell at me. It's much easier to just have one method to take care of all of this. All that's gone. Just one method. Leverage polymorphism, code it to the abstract class. If there's no common base class that they're all inheriting from, set up your inheritance. Create one. Create one so you can do things like this. Reorganize your code. Get all the common functionality out into a common abstract class, and then extend that class all over the place. All right, so let's fix our rock. And this is where override is going to be nice, because I don't remember exactly what it is. Actually, I think I do. It should be public void use that takes a reference to a player. But if I did anything wrong there, my annotation is going to take care of me. If I have use, if I mistype this, my annotation is going to kick in and say, hey, something's wrong. You should probably take a look at this. In fact, if I have a lot of different player classes in this code. If I do the wrong one, maybe I grab my starting point player. It's also going to catch that, which is a very nice thing to have. So I'm importing a different player, so I'm not getting the player in this package anymore. I'm importing a different one. And now this player, even though this method looks perfectly fine, my override annotation kicks in and says, hey, something's wrong. You got to look into this because you're not overriding any methods. And the problem is that I have this import statement. And if I let IntelliJ, I don't even know what it's going to give me here. It gives me the fully qualified. So if I tell IntelliJ, well, fix my error for me, it'll give me the fully qualified name to make sure that I'm getting the right player. This can be a pretty confusing one to encounter if you see this out in the wild, of why does this not work, but now I have to specify the whole path, the whole name, the fully qualified name of my class. It's because you have this import up here. The solution is to just get rid of your import and have it work that way. This is most commonly seen with comparator. It's the one time where I use a class name that does exist in Java. So there is, let me actually show this one off. So there is a Java comparator. If I import Java util comparator, none of my code is going to work here. None of my stuff works because I imported Java's comparator. So now these comparators are Java comparators, and int increasing does not implement Java's comparator interface, which is an interface which does basically the same thing we do, except it returns int. It's the Java style of comparator, but otherwise pretty much the same thing. Oh, and it does use the default keyword and has an equals. I didn't know that Java comparators had an equals actually. Why wouldn't I just check if compare returns 0? That's probably what the equals method actually does in the implementations, if I were to guess. And then a few default things. So I guess it has some extra stuff here. But the important one is the compare abstract method. But if you import this, now you're getting the wrong comparator and just everything breaks. So don't import things. That's almost always the case of somebody letting the IDE write code for them, which don't do. If the IDE is writing code for you, at least double check what it's doing for you. Because if it imports Java's comparator instead of using the comparator we're using in class, in the one that's given in your in the homework handout, then you get issues that are kind of hard to find, unless you know specifically to look for that. So all that to say, another reason I like my override annotation, it makes sure I have the right player class here. And we'll get a rock. Should something happen to the player too? Player dot. I don't know if anything makes sense. We'll increase their damage output. I don't have a getter for damage. Public. Is damage dealt an int? Yeah. Int. Get damage dealt. See, I let the IDE complete that for me, but I'm double checking, make sure make sure everything's the way I expect it. Return this dot damage dealt. There's my getter. Get damage dealt. Let's bump it by 1. Okay. So we have game item as an abstract class. The use method is going to be abstract. And then every extending class has to override the use method to do whatever specific thing that item does. Health potion. I'm definitely blaming Impala for this one. This one drives me nuts. Oh, it would have to be... Oh, never mind. I'm not going to bother then. I just created this file, so it's not in Git, so I can't show that yet. But taking negative damage instead of actually healing the player, let's rewrite this. Set. Of course, we don't have our getters and setters for this either. Get HP. We just don't have any setters for those. I just want all my getters and setters. Here we go. Now we have every getter and setter. Player dot set HP math dot min of player dot get max HP and player dot get HP plus this dot increase. That's a bit better. So we'll heal up to the max HP. Much better than taking negative damage with no max HP cap. But we're overriding the use method with health potion specific behavior, with weapon specific behavior. Using a weapon, we're going to say we're equipping that weapon, so we get that weapon's damage output as our is the player's damage output now. And then rock, we're going to, I don't know, increase our damage by 1. Maybe we're melding it to our weapon or something. I don't know. Just so it does something. And that's our new setup for this code. Do we want to... Oh, inventory. We haven't done inventory yet. All right, so private... We want to create inventory, but we want to be able to store any type of game item. So array list of game item, inventory, and I'm going to initialize it right in line here. New array list for our inventory, and then we want to have code that interacts with our inventory. I'll put it right here just so we can have the instance variable on screen at the same time. Public void pick up item is going to take a game item this dot inventory dot add item, and then public use all items for game item in this dot inventory. This dot, I'll do this a little different than the slides, just to, I don't know, just to do things different. This dot use item. So I'll call another method. Call our use item method, which is way down here, which will call item.use. And then if I want to use a specific item, public void use item at index, I'll call it, which will take the index of my inventory that I want to use. I got to be a little careful with this one. So how complex do I want this? I guess it doesn't get that complex. So let's max out the complexity. It won't be that tough. So we want to do a few checks. If index, because I don't know who's calling this method or how they're calling this method. So they might give me some invalid indices. Just I want to have some checks here to make sure that that we're not going to break things. So if index is less than 0, that's going to break things. Or if index is greater than or equal to this dot inventory, inventory dot size. So if this index is invalid, I don't want to do anything. You can't use an item that doesn't exist. And we're at the point of the semester, actually we've been at the point of the semester, where I want to show more tricks in coding. I don't have to show you like the simplest way to get things done anymore. I'll show you more interesting things. Not that this one is super off the wall or anything, but you can use a return statement in a void method. This is sometimes helpful when you want the method to end right there. So if this is the case, what you can do is else and put all of your logic in the else statement. But I won't say problem, but one of the concerns with this is that your code gets indented one more level. So if you have another if else and you have a bunch of checks like this, your code's going to start getting indented more and more and more and more, and it just gets a little harder to read, a little more of a pain to work with that code if you keep doing that a whole bunch of times. So instead of having an else block, to avoid the else block, you can return here and say if my sanity check, if this hits, then just return, just be done. Or do this the other way if there's the other way has the same issue. If not this, if we don't have any issues, then do the thing that we're trying to do. That has the same issue. You're indenting one more level, which I use the word issue. I don't want to use the word issue there because it's not really an issue. It's more of a stylistic choice. More of a readability concern. It's definitely debatable. Some devs will do it this way. Some devs will do it with an else block, and both are perfectly fine. But just to give you an option, if you don't want that indentation, if you want that to be part of your coding style, make sure this returns. Even if it's void, just use a straight up return. And now all of the logic of your code can be at the lowest indentation level, the indentation level of the method itself, instead of getting indented one more because you had this check at the beginning of your method. So now if I ever get here, I know that I never hit this return, which means this was false. So I know that I have a valid index, but I'm still at the first top level indentation level. Okay, so now we can go this dot inventory dot get of that index. That gives me the item that I'm going to use, which is a game item. I don't know what type of item it is. I don't care. I just know when I'm writing this code that I have to use that item. So this dot use item. Actually, let me show another thing since we're in tips and tricks territory here. You might be tempted to do this dot use item. This dot inventory dot get index. I guess that actually works here. You know what? We don't have to do it the other way. Yeah, that actually does work here. We don't have the issue that I was trying to solve there. So let's just do it this way. We're going to use the item at that index, and then this dot inventory dot remove index. You know what? I'll show it the other way also. It doesn't really come up in this case, but I'll show you what I was thinking. So here's one way to do it. Use the item and then remove it from your inventory. The one issue that could possibly come up, probably won't ever be an issue in this specific example. But let me set it up and then finish my thought there. Game item equals this dot inventory dot get of index, this dot use item, this dot inventory dot remove index. So this is effectively doing the same thing as the other code. The possible concern is that you're using an item that's still in your inventory. So thinking of the kind of order of how things should unfold here, we might want to not do that. So we might want to use an item after removing it from our inventory. So we're going to remove from our inventory that item and then use the item. The order can be important here. A situation where this might arise is when you have concurrent code, which in a game you're going to have concurrent code, which means chunks of code that can run at the same time. You have to have concurrent code because your game, no matter what, this is a little bit of a rabbit hole, but hey, we have some time here, and I don't see questions in chat, so this is what I mean. I'm just going to go off on whatever I want to talk about. If left to my own devices, but if y'all have questions on the tasks or the content, the concepts, I'd be happy to go over those. Otherwise, I'm gonna just ramble on whatever comes to my mind, and this is what came to my mind here. This might be the way you want to do it because you have concurrent code, because your game is running, it's updating the physics, it's updating the graphics. It's using inventory items, changing your HP, your MP, doing damage calculations as you're in combat, and also listening to player inputs. You have to listen for keyboard presses and mouse clicks, mouse movements. You're always listening for those as well. So your code has to be concurrent because it has to be doing at least two things at the same time. It's at least updating the game world with the physics engine and everything, enemy AI movement and everything. Is doing all of that, which doesn't necessarily have to be concurrent. It can do all of that stuff, one thing at a time. But while it's doing all that, it has to listen for player inputs. So at least has to be doing two things at once: updating the game world and listening for player inputs. So once you have code that's running concurrently, you might have concurrent reads and concurrent write. I did forget about debugger. We'll run this code in the debugger and get some good debugger tips today. So there has to be two things happening at the same time, which means you can have concurrent reads and concurrent writes, meaning in general, two pieces of code are trying to access the same data at the same time, or the same data structure in this case, which is our inventory. If two pieces of code are trying to interact with the inventory at the same time, so your game is updating and using that inventory item because the player told it to use that inventory item, and the player's trying to use either that inventory item or another inventory item before your code finished using the previous one, you can start to have strange bugs in your code. So in this case, if I remove the item from our inventory first and then use it, I would avoid a situation where, let's say, a player uses the item and then we remove it from our inventory. There's a small window of time here where we grabbed the item from the inventory by reference. We're about to use the item, or we're in the middle of using this item. Maybe this item's code, maybe this item's use item method takes a long time to run. It has some inefficient code. It's got a whole bunch of calculations to do. Maybe this takes, 10, 20 milliseconds, or even like 3 frames in your game. Maybe it takes 3 full frame updates for this to happen, which is a long, long time. But maybe it does take that long. Maybe it just has a lot of work to do. Well, now there's a 3 frame window for your player to use that item again, because it's still in their inventory. We haven't gotten to this line yet, and they're going to use it a second time. Now we have this item used twice when it should only be able to be used once, but if we remove it from our inventory first, remove it from the player's inventory, then use it, now the player can't use this item twice because this is going to be instant. As soon as they use it, it's not going to take a full frame just to remove that value by index. That's going to be immediate. And then even if this code takes a while, there's no window for the player to abuse that and start doing like item duplication glitches and stuff. If we remove it from our inventory first, like if while the item's being used, they remove it from their inventory by like clicking, dragging, whatever, and just drop it on the ground. Now we have like item duplication glitches and all kinds of crazy stuff. Remove it from our inventory first and then use it, or just in general, when you have something in a data structure, you might want to remove it from the data structure first and then work with that value that you've removed. Or depending on the application, you might want to do it the other way around. Programming is interesting. There's a lot of different unique situations you're going to come across. You might want to use it while it's still in your data structure. But at any rate, it's something you should consider and something you should think about when writing your code. All right, so let's set up an example for this. Do we have health potion player? Let's use this one. Player, we got a new weapon. Let's get a rock. Let's store a rock in a game item variable. We'll make it a 150.7 pound rock. I'm going to use pounds in this, which is at 5, -10 coordinates. And a health potion. Potion equals new health potion, which is going to be at the origin and heal us by 10 HP. The player P1 is going to pick up all 3 of these items. Weapon is just W. That has to be Paul's variable name. Pick up item. I would never do a single letter variable name. Unless it's like X or I. Pick up item potion. P1 dot use item at index 1. So this should use the rock. Use item at index 1. We don't need the print lines. Or do we? And then let's do use all items. I'll leave the print lines there just for the fun of it. All right, and then let's run this in the debugger. Debugger tips. So there are 5 buttons on the debugger that I primarily use. I guess 6. I'm counting them real quick. 6 buttons that I'll primarily use. So we got 10 minutes. Let's try to get at least one example of each of them. Actually, this is a good reason to use the first one. So these 3 here: step over, step into, step out, restart, resume, and stop. I guess stop is the one I don't really need to talk about. That's just when you're done using the debugger, click stop. So there's 5 interesting ones that I want to talk about that I use pretty much exclusively. I don't really have much reason to use any other ones, unless you count the console tab as a button, which is going to show you what's being printed to the console, which can be helpful. Which printed the rock being used because I realized I never set a breakpoint. So we're in the object class here. because I set a breakpoint in the object's toString method, which I forgot about. So I want to undo that breakpoint, but then I also want to resume execution. If I start doing step into, this will advance by one line and go into method calls. I can keep clicking this, and I'm just lost in Java code for a while. It's going to be a lot of stuff that I'm not interested in, and it's going to take a while to get out of here. Now I can do step out and go up a stack frame and start going. This will run. Actually, I can talk about a lot of the buttons right here. This is a good, perfect example. I can do step out, which is going to run until the current stack frame returns. So I'm in this to unsigned string. Like, I'm way deep into Java stuff here. Stuff I don't care about. Aside from just some mild curiosity of how it works, I don't need to know how any of this stuff works. How the toString method calls toHexString, which calls toUnsignedString. So this will end the current stack frame. And then once that stack frame returns, it'll stop the debugger again and say, okay, here's the current state of memory at this point in time. And I can keep clicking that until I get back to some code that I'm interested in. And by the way, you can see the main method called println, which called value of, which called toString. So the player's toString method is being called by println. Even though println is internal to Java, it does eventually call our toString method. I've said that multiple times throughout the semester, but it's cool just seeing it in an actual stack in running code in the debugger. In the debugger, if it's internal to Java, it'll highlight it in orange like this, which pretty much says, you don't care about this information, but it is on the stack. Anything not highlighted in orange, that's our code that's being executed. But anyway, I could keep clicking step out, but instead I'm going to click resume. What resume will do is continue running the program until we hit another breakpoint, which I don't think I set another breakpoint, so I think this just goes to the end of the program. If I resume here, yeah, it did. And if I go to the debugger's done, there's nothing in memory anymore because the whole program's over. And on the console, I can see everything that was printed to the screen, plus a bunch of debugger output. But here's what was actually printed to the screen during the execution of my program. So now let's actually set a breakpoint. And let's set a breakpoint right here. Then I'm going to run that again in the debugger. And now I hit the actual breakpoint that I'm interested in. So let's stop right here. We have P1 weapon item, or weapon item potion. Potion, everything what we expect. The one interesting thing, item of type game item does store a rock. It does have a wait instance variable. It is still a rock object. It just happens to be stored in a variable of type game item. Can I join? I don't know what you mean by that. You can ask questions. But we only have 6 more minutes, so there's not much time for questions either. So step into. So we just saw step out. Step into is going to go advance your code by one line, but it's going to go into any stack frames that are put on the stack. So we're about to go into this pickup item stack frame. Step into is going to go into the pickup item method. So we went into that stack frame that was on the stack, that was added to the stack. And we can see our reference. This is going to be a reference to the player. The debugger is going to show you whatever toString will return for that type, which we have is some mangled, this mangled thing that was used as a lecture example. Super.toString. Super from the player class. Oh, because I know why. But super for the player class is the object method, or the object class. So we're getting the object's toString method here, which is the default kind of garbagey thing here. And we're going to advance one line that added that item to our inventory. So our inventory has a weapon in it now. like we would expect. And then we're on our next line. If we do step into again, we're going to get into pick up item again, then pick up item again. That's kind of boring. So I'm going to use the next button, step over, which is going to advance by one line, but it will not enter any new stack frames that are called. So step over, it's going to skip over that whole stack frame. So that pick up item stack frame, it still happened. My inventory still got that rock inside its inventory, but it didn't. The debugger didn't bother showing me any of the code because I said, you know what, I'm not interested in this method call. I'm going to do the same thing here. For picking up the health potion, I'm like, I get what the pickup item does. I've looked at that method. I believe it's doing what it's supposed to be doing. And if not, I'm still going to check my inventory and make sure that health potion made it into my inventory. But I don't need to step through every single line of the code. I mean, it's only one line of code in this case. But I don't need to go step through all that code. Just step over and I'll make sure that it did what it was supposed to do. And it did. So I'm happy about that. And then use item at index 1. This is brand new code. We haven't tested this at all. So this one I do want to step into. And I want to check out if this method does what it's supposed to do. Oh, actually I should. Let me go back to the... What are we running? Weapon? Let's use... So I'm going to change the code. Let's use -1. Like this would be a good test case. And like 5. And I want to change my code. And the debugger will not run the new code. It won't see those changes. So I'm going to hit rerun. Rerun this thing. And I didn't move my breakpoint. I still have my breakpoint here, but I'm really interested in use item at index. I don't want to have to click step over, step over, step over. I mean, it's not that big of a deal. It's 3 clicks, but anything I could save. So I'm going to set a new breakpoint where I'm now interested in, and then click resume. This runs until it hits another breakpoint. So it goes over all those pickup item calls. Those calls still happen. I still get all that stuff in my inventory, but it's not going to show me all the details. Then I can get rid of this breakpoint because I'm done with that code. Like, I believe all of this code is doing what it's supposed to be doing. There's no bugs. I'm not interested in seeing how that works anymore because I'm pretty confident that's all doing what it's supposed to be doing. But here's where I want to pick up my debugging because I haven't seen use item at index in action yet. So let's make sure this is doing what it's supposed to be doing. So index less than 0 was true. So this never got checked. This got short-circuited. This never executed because this is true. True or whatever is always going to be true. So we go into the conditional. I can go over to the console to make sure that was printed to the screen. And then it just returns that ends the method. And we didn't have any errors. Program didn't crash. We didn't get index out of bounds errors because we checked for our bounds. Same with 5. This time we have to get to the second check. Index out of bounds, but don't crash. And then our third one, we actually get to run our code because our check didn't kick in this time. Now we're getting that item out of our inventory. So item is that rock, which is at index 1. We're going to remove the rock from our inventory. So we expect everything to, to update the way we expect. The rock is removed, and then everything after that is advanced up by 1 index. So health potion is now at index 1. So our inventory is how we expect it. And then use item is going to call the item's use method. The item is of type rock. So we're going to end up in the rock class for looking for that method named use. If we don't find it, we would go through our progression. We would go to game item, do our same thing we've done before. But we do find it in the rock class. So we're going to call some getters, setters, some stuff that I'm not super interested in. But we're going to look at the player. Its damage delta is 4. After this line, we would expect damage dealt to be 5. So I'm going to step over all those getters and setters and make sure damage dealt is 5 after all of that happens. And then whether I do step over, step into, or step out of, all 3 of these are going to do the same thing right now because we're at the last line of the method. I'll do step into. That's usually my default. Actually, I guess it didn't technically do exactly the same thing. And then I want to make sure that was printed to the screen. I got a rock. And we're back out here, and everything looks like it happened the way we expect when we used that rock. And since rock was the second item we added to our inventory, we expected that to be at index 1. And then use all items. We're going to iterate over our game inventory, or over our player's inventory, which is weapon, then health potion. So item is going to be our weapon. So use item. Use is going to be the weapons use method, which is going to set the player's damage to 10. So our damage dealt, or sorry, 20. Our damage dealt is going to go up to 20. We hit the next iteration of the loop. We're going to use the health potion, which is going to heal us by 10, but we're at full health already, so we expect this to not do anything. We're going to go through all those getters and setters and everything. I'm going to skip over all of them. And my player health, the checks didn't work. Well, let's we actually have something to debug here. So math.min, player.get max HP, player.get HP plus increase. I got an old parenthesis imbalance here. So I want to see if that does work. So I'm going to set a new breakpoint right there. I'm going to restart the debugger. Because we found a bug. I didn't even do that intentionally, but I should have. We found a bug. We changed our code. So I want to rerun my code. I don't want this breakpoint anymore. I'll leave it there, but I'll click resume, which should get me right back to where we were because I'm only using one health potion. So if I get into the health potions use method, it should be right where we were before. Player is going to have 10 health. I'm going to step over all the getters and setters. Now our cap is kicking in properly the way we want it to. HP is now 10 instead of 20. So we found a bug. We eradicated it. We used all our items. And then toString. We've seen toString during the inheritance lecture. So I'm going to step out of that and just step over and make sure we do get some things printed to the screen. Yeah, we even went 2 minutes over with all that stuff. Good content. Good stuff. Then stop the debugger and be done with it. Cool. I'm going to take my break and be back for the 11 a.m. lecture. Y'all have everything you need for Test 7. We talked about how we're going to mix songs and movies in this media library class and in the return of the top K ratables. I kind of gave some heavy-handed hints about how to solve this also. I don't think Task 7 is as difficult as some of the previous ones, as I mentioned. The time estimates is kind of my way of saying that too. 4 hours as opposed to 7 hours for Task 6. 6 hours for Task 5. Like, I expect this to take less time. It's a little bit of an easier task, in my opinion. Some of you will end up disagreeing because you'll run into very specific bugs that'll make it more difficult. But overall and on average, I think Task 7 is a little bit easier than the last few tasks that you worked on. I think, yeah. All right. Take care, everybody. Have a good one, and I'll see you Thursday. Take care.